Hi, Angela.
Hi.
Sorry about that. I can't say I've ever had to do that before. I had it happen once right at the end of a session, and my computer just went crazy. That's a bad feeling when you don't have control over your cursor.
Oh, I know.
It makes it,
I know computers, they're great until they go bad.
yeah, this makes me always feel like somebody's in my computer and has control over it. I don't know. Maybe I have been hacked, but
There
I
could be,
don't think so.
a virus.
Well, it always happens when I get my wireless mouse and my wireless cursor too close to one another, and which is what happens in a session because I'm using my cursor to draw on this tablet here. All right, well, we finished with that particular practice type question. Let's go to the quantitative comparison questions.
Okay.
So number 1. I don't know if you can read those. That's 197 plus 398 plus 586 compared to 203 plus 405 plus 607.
And quantity B is going to be greater.
Good. And hopefully you notice that without using a calculator.
Yes.
Okay. X is greater than 0. What's bigger, 10x or 10 divided by x?
Well, let's see. If X is 1, they're going to be the same.
Okay.
And then if X is 2, so it can't be determined.
Okay. Time that it takes to type 7 pages at a rate of 6 pages per hour versus the time that it takes to type 6 pages at a rate of 7 pages per hour.
That one I almost feel like I have to calculate it.
Actually not. Is the time in quantity A greater or less than 1 hour?
Well, let's see. The time that it takes to type 7 pages at a rate of 6 pages per hour. So it's going to be, if they're typing 7 pages, then it's going to be more than an hour.
Okay. How about quantity B? Less than or
less than
more
an
than
hour.
an hour? That's less than an hour, right?
Right.
So
quantity A is
yeah.
bigger.
And we didn't really have to do any math other than just notice how it relates to the number 1.
Okay.
Which is fairly frequent in math. The number 1 is definitely a more important number than a typical number. So here we have C times D is less than 0. So which is greater, quantity C plus D squared or C squared plus D squared?
I believe quantity A would be larger.
Okay, expand that for me.
It would be C squared plus 2CD plus D squared.
And we're comparing that to C squared plus D squared. Well, so now we're comparing 2CD with 0.
Oh, okay. And yeah, 2CD is less, CD is less than 0.
Okay, so 0 would have, the right side would have to be bigger.
Have to be larger.
Yeah, okay. A, B, and C are the measures of the angles of an isosceles triangle. X, Y, and Z are the measures of the angles of a right triangle. What's bigger, the average of A, B, and C, or the average of X, Y, and Z?
They're going to be the same.
Good. Number 6. I won't spend a lot of time on these if it's clear you're doing it quickly or the right way.
Yeah. Yeah, those ones I understand.
Okay.
I believe.
Okay. Number 6, which is bigger, 6b. B is negative. Is 6b or b to the 6th?
Quantity B would be bigger.
Okay. Wish they were all this easy
Boy, me too.
on the quantitative comparisons. Area of a circle whose radius is 17, the area of a circle whose diameter is 35.
It's going to be B.
Line K goes through 1, 1 and 5, 2. Line M is perpendicular to line K. Which is bigger, the slope of line K or the slope of line M?
Now this one I'm not going to get.
Okay, we need to go over the slope then. What's the definition of slope?
Rise over run.
Slope is rise over run. That's the one I like everybody to memorize, because from that you can always get the more technical definition, which is what? What's the rise equal to?
The rise is equal to y2 minus y1
And the run?
is x2 minus x1.
So let's solve for the slope of line K.
Okay, so it'd be 2 minus 1 is 1, and 5 minus 1 is 4.
So it'd be 1/2. Now, the next principle you need to know is how the slope of a line that's perpendicular to this line. In other words, that line says we have a slope of 1/2, so it's about like that. Goes up 1 over 2. What's the slope of a line that is perpendicular to that line?
It's going to be the opposite.
Exactly. In fact, it's actually the negative reciprocal. So what's the negative reciprocal of 1/2?
It's going to be -2.
Okay. The key part being you said it was opposite. And that's all we need to know to answer this question, is that it's opposite. So clearly the positive slope is the larger number. And the positive slope was from line K. So quantity A is larger than quantity B. This negative reciprocal, didn't really have to know that. You just needed to know that it was opposite for this question, but you do have to know that negative reciprocal for other questions.
Okay.
So that's worth memorizing. In other words, if I have a slope of minus 3/5, the negative reciprocal of that is 5/3. In this case, if you didn't know any of that stuff, you could plot those 2 points. One point would be right there, the other point would be right there. You'd see it has a positive slope. Draw a perpendicular to it, you'd see that has a negative slope. In other words, you really could solve this graphically if you didn't remember any of that geometry.
Okay.
This is one of their trick questions almost. Not really a trick question. It's just very hard to interpret it properly. A lot of their questions are like that. I notice that whenever I come across a question on the GRE that I miss, it's always I've missed it because I haven't read the problem and interpreted it correctly.
Okay, that one I'm going to say can't be determined.
Very good. Very good. If I said to you, which is bigger, the number of multiples between 0 and 100, multiples of 6, or the number of multiples of 9 between 0 and 100, what would you say?
I would have said quantity A.
Okay. And that is the way that I first misread this problem, was between 0 and 100 instead of between 100 and x plus 100. But you read it correctly. Let's see, do I get all the information on this? Yeah. So we have x plus y equals 5, and y minus x equals minus 5.
Okay, so in this case, they're going to be equal.
Good. Again, when they list it like this, the first thing that comes into my head is I'm going to solve these by elimination. And if I add them, the x's disappear. I get 2y equals 0. Y has to be 0. Number 11.
Quantity A is going to be larger.
Okay. Key principle here is when you take a number greater than 1 to an exponent, it gets bigger always. If you take a number between 0 and 1 and you raise it to an exponent, it gets smaller. So if you raise it to multiple exponents, it gets smaller still.
Yeah.
Okay. Well,
Well, I know that if we did a diagonal, that would equal 6.
it's a good start.
And so the other sides would be 6 over the square root of 2.
Good. Using similar triangles.
Yes.
Very good. Okay. Now, here's a case where don't concern yourself with rationalizing that,
Okay.
because we don't need to rationalize it. We need to figure out the area of the square, and sometimes that problem will eliminate itself, which it's going to. In other words, there's nothing wrong with this as a number. That's a perfectly fine number. It's just by convention that's never given as a final answer.
Okay.
So it would always be rationalized. If they were asking for what the side of the square was, you would not see this as one of the answers. You would see 6 root 2 over 2, which is the same as 3 root 2. But in our case here, there's no need to take that extra step, because the very next step of your problem is what?
We're going to square it.
Right. So when we square it, we get 36 over 2, which is 18. So the area of the square is 18. What's the area of the shaded region?
That one I'm not sure how to come up with.
Okay. What shaded region problems are always subtraction problems. So what are we going to be subtracting here? We need the area of this quarter circle minus the area of that square. Well, to get the area of the quarter circle, and we know it's a quarter circle because if this is a square, this is a 90-degree angle. So how would I get the area of a quarter of this circle?
Use the area of the sector?
Yeah, but that is the area of the sector. So what is the area of the sector?
What's going to be 90 degrees over 360 degrees?
Times the area of the circle, right?
Yes.
What's the area of this circle?
And the area of the circle is, let's see, area equals pi r. Let's see, the radius is 6, so 36 pi.
So that's the area of the full circle. So what's the area of this sector?
18 pi.
Be 9 pi.
Oh, 9. Oh, yeah, geez.
Because it was 90 over 360.
Right.
Now, it's good that you know the areas of sectors. In other words, had that been an 89-degree angle, you could have given me the area of the sector.
Okay.
Perhaps a simpler way to look at it, though, is that that's a quarter circle.
Okay.
So we don't really have to go to the trouble of doing 90 over 360 to get that quarter.
Oh,
If
okay.
you think of circles as being full circles, semicircles, or quarter circles, then that kind of saves you a step, at least mentally. But either way, we get 9 pi. So the shaded region is what?
I got lost.
Okay.
9 pi.
Well, that's the quarter circle.
Okay,
So
so
9
the
pi
area-
minus 18.
right.
Okay. Well, I'm still not positive that we're done doing math. Can you tell right offhand whether that or 12 is bigger or larger?
You can tell that 12 is larger.
Okay. In other words, without using your calculator?
Yes.
Okay. Because you know this is going to be at most 28.
Right.
3 times 9 is 27, and 0.14 times 9 is not going to get it to 31, which would be where it would need to be to get it bigger than 12. So another shortcut, you don't actually have to do this math once you get it to that state. But this was actually a pretty good problem. It had quite a few pieces to it.
Yeah, it did.
You had to use the similar triangles. You had to recognize, first of all, that all radiuses are equal, so the diagonal of that square had to be 6. And then use similar triangles to get the side of the square, and then use the shaded region, knowing its subtraction, and then figuring out the area of the sector, and all of that. So I guess they're not all real easy.
If only they could be on the actual GRE.
Yes. Well, it's computer adjusted, right?
Yes.
So you hope they're not all real easy.
Well, that's true.
Because if they are, you're not doing well.
No, and if they were all easy, anybody could do it.
Well, but it is a very mixed emotional bag. It must be when you're taking it, because the more difficult problem causes frustration, but at the same time it tells you you're probably doing well. You're
Right.
doing okay. So you want to see difficult problems. Okay, the number of square inches in the surface area of a cube. Oh, speaking of that, I just I didn't lose my train of thought. I had another idea. There is a site called MBA.com that lets you take practice tests in real time on their system.
Oh.
I wonder if GRE has an equivalent thing. I'll bet it does.
Oh, but it does too.
Yeah, and it proved this one guy I worked with for a couple of years because he was very insistent that he wanted to get into one of the top business schools, and so he started out with like a 550 on his GMAT, and he ended up getting it up over a 700, but it took him a long time. We worked a long, long time.
Yeah, I may end up having to reschedule mine because I don't feel anywhere close to ready for it yet.
Well, we're only halfway through. I'll bet you by the end of another 6 sessions, you'll be a lot better off. I'm noticing that principles we're covering one day, you've learned by the second day. And that's a real good sign. So,
I'm trying.
yes. Okay, so the number of square inches in the surface area of a cube is equal to the number of cubic inches in its volume. So what's bigger, the length of an edge of the cube or 6 inches?
Okay, let's see. The number of square inches in the surface area of a cube is equal to the number of cubic inches in its volume.
Now, I would not necessarily suggest you draw this diagram, but
Okay.
it can be helpful. And for no other reason than it kind of directs you in a way to proceed. If you don't really know how to proceed here, then the diagram is going to be helpful. What's the volume equal to?
Edge cubed.
What's the surface area equal to?
6 edge squared.
So if the volume's equal to the surface area, then x cubed is equal to 6x squared. So what is x?
So x is 6. Or, yeah, x equals 6.
Mm-hmm. So they're equal.
Yeah. Okay.
Okay. I'm not sure how you solve that. In a problem like this regarding dimensions, it's okay to divide both sides by x squared, immediately producing this. In general, from a mathematical point of view, you can't do that if x can be 0. But since x can't be 0 here, that's not of concern. In other words, the other way to do it would be to subtract 6x squared from both sides and solve that. Now you factor out an x squared and you get x minus 6. And that equals 0. So your two solutions are x equals 6 and x equals 0. The only way you find the 0 solution is by solving it this way. Bigger, pi x or x squared? And x can be anywhere between 1 and 4.
Okay, it looks like quantity A.
Okay, let's try some numbers. If x is 2, quantity A is bigger. Now let's go towards the other end of the spectrum. Now, this process that I'm doing here, I actually could have used 1 and 4. Even though it says greater than 1 and less than 4, for me to do my my comparisons, I can use those two numbers. Because clearly x could be 3.9999999. So for the purposes of comparing, I can try x of 4. Well, if x is 4, which is bigger?
Quantity B.
So, in other words, we can't tell.
Correct. Okay.
Okay? Now, you didn't have to use 4. You could have used 3.9 and determined that quantity B was bigger with 3.9. You have a calculator, so you could square 3.9. But I've seen this concept come up before, and I remember my other student objected to me using 4 in this case because it can't be 4. But it makes the math so much simpler, and from a logical point of view, it's the same thing. Okay, let me open the next page. Ooh. Problem 15, I wonder.
And you know what? I was going to say, if we could stop at that one since we got to the end of it.
Uh-huh.
And then maybe go ahead and start it, you know, on, I scheduled an appointment on Thursday.
Okay, sure.
And then maybe we can just go ahead and start with the next one on Thursday.
Okay, sounds good. Okay, so we have an isosceles triangle here. That's what's given us. And its height is 6. If you don't know what to do, we could draw a picture, or we could start. Usually what I tell people when they don't know what to do, start with whatever you know. Since one of the questions is the area of a triangle, let's just start with the area of a triangle. What's that equal to?
1/2 base times height.
Okay. So in this case, it's 1/2 base times 6. And we're comparing 1/2 base times 6 with the number 3.
So we'll have 3b and 3.
I wonder if there's a mathematical symbol for compare to. I don't want to write it's either equal to, it's greater than, or it's less than, or it's less than or equal to. So which of these possibilities is it?
I'm going to say that 3b is greater than 3.
Would it be is less than 1?
I'm sorry, what was that?
What if b is less than 1?
But it can't be, can it?
Well, the only thing they're telling us is that this is an isosceles triangle, which means I can draw it in lots of different ways. I can draw it like this, or I can draw it like this. In other words, I can make that base whatever I want as long as that height is 6.
Okay, so in this case, since the base can be anything, it can't be determined.
Exactly. Exactly. In other words, drawing a picture might have actually solved it a little quicker.
Yes.
Instead of writing that formula, because if I would have seen that I could draw it in either of these modes, in other words, if I realize that I don't have to draw it, this merely says that AB is equal to AC. It's isosceles. But you can draw isosceles triangles, tall and skinny, or equilateral, or wide and fat. So since the area, I can clearly graphically see that this area is a lot less than this area. And there's really not much limit as to how small I can make that. In other words, I don't even need to know the formula for the area of a triangle. All I need to be able to see is that I can change that base to almost nothing.
Anything, yeah.
Yeah. and I can also make it really big. So I can make the area of this triangle whatever I want. A number less than 3 or a number greater than 3?
Greater than 3. Okay.
Okay. All right. Well, let's stop with that. And let's see, you have another appointment tomorrow or Thursday? Thursday morning?
Thursday.
Thursday
Yes.
morning. Oh, I remember what I wanted to ask you. Yeah. I actually have a 9 o'clock if you'd prefer it on Thursday. I had made a little note on that day, and that's what reserved that half-hour spot. That didn't
Sure, 9 o'clock would be
didn't
great.
let you make it at 9 o'clock. So I'll change it to 9 just so we'll be
Okay.
consistent.
That sounds good.
Okay. And I will talk to you on Thursday, Angela.
Okay, thank you.
You're welcome. Bye-bye.
Bye-bye.